There is a principle in engineering that necessity drives invention. But there is a stronger version of that principle, one that only applies when the alternative to invention is annihilation. Israel did not choose to become the world's most aggressive modifier of foreign warplanes. It was pushed there. By embargoes. By wars it did not start. By the simple arithmetic of a country surrounded on every side, with no friendly neighbor to call for spare parts and no time to wait for the next arms deal to close. What follows is the story of every aircraft the Israeli Air Force ever took, stripped down, rebuilt, and sent back into the sky as something different. Some of these transformations were small, others were so fundamental that the original manufacturer barely recognized the result. Together, they form a documentary record of what happens when a nation decides that survival is not a budget line. It is an engineering problem, and engineering problems have solutions. Chapter 1. Stolen Blueprints, the French Years. The Israeli Air Force received its first Mirage 3CJs in April 1962. The aircraft was called the Shahak, Sky Blazer, in Israeli service. It was France's best fighter at the time, a Mach 2 Delta Wing interceptor with a Cyrano radar and French-supplied missiles. Israel received 72 of them across several variants. The modifications started almost immediately. Israeli aircraft industries fitted a removable nose module that replaced the radar with a camera package, turning the Shahak into a reconnaissance platform without requiring a separate aircraft. It was an elegant solution. One airframe, two missions, depending on what you bolted to the front. The missiles were a different problem. The French Matra 530s that came with the aircraft were so unreliable that most Israeli pilots refused to use them in combat. They fought instead with the Defa 30mm cannons, guns that rewarded precision and punished hesitation. By the time Israeli Mirage 3s were retired in 1982, they had accumulated 397.5 confirmed aerial kills. No other nation that flew the Mirage 3 came close to that number. The modifications were part of the reason. The pilots were the rest. Then, in 1967, France cut off Israel entirely. The embargo covered weapons, spare parts, and the 50 Mirage 5 airframes that had already been built and paid for, sitting in Dassault's factory in complete condition, ready to fly. Israel had ordered them, funded them, and would never receive them. What happened next is one of the most audacious acts of industrial espionage in the history of aviation. Israeli intelligence acquired the technical blueprints for the Mirage 5. Engineers and sympathetic Dassault employees passed manufacturing jigs and subassemblies through channels that have never been fully documented. And Israel Aircraft Industries went to work. The result was the Nesher, Vulture. It first flew on March 21, 1971, and it was, in every meaningful sense, a Mirage 5 built in Israel without French permission. 51 single-seat fighters and 10 two-seat trainers were completed before production ended in 1974. Every aircraft carried Israeli avionics, a Martin Baker 00 ejection seat, and provisions for the Kfir, an Israeli-developed heat-seeking missile. During the Yom Kippur War of October 1973, Nesher pilots claimed over 100 aerial kills. The aircraft that France had refused to sell proved itself in the skies over Sinai and the Golan. When the Neshers were eventually retired from Israeli service, Israel sold them to Argentina. The Argentinians called them daggers. They flew combat missions in the Falklands War in 1982. But the Nesher was always a stopgap. Israel had already started working on something more ambitious. That ambition starts with the engine. Chapter 2. The Lion Cub, rebuilding France with an American heart. The Nesher was a copy of the Mirage 5. The Kfir was something else. It took the Nesher airframe and replaced the French Snecma Atar engine with a General Electric J79, the same power plant used in the American F-4 Phantom. That one change cascaded into a total redesign. On September 21, 1970, before the Nesher had even entered service, IAI flew a modified two-seat Mirage 3BJ they called the Technologue. It was a testbed, a proof of concept. The question was whether the J79 could fit inside an airframe built around a completely different engine. The answer, after months of testing, was yes. The Kfir C1 entered service in April 1975. It produced roughly 2 additional tons of thrust compared to the Atar it replaced, and pushed maximum speed to 1,520 miles per hour. Israel had taken a French fighter, ripped out its engine, and installed an American one. But the C1 had a problem. At high angles of attack, the aircraft was dangerous. The aerodynamics at the limit of the flight envelope were unpredictable in ways that killed pilots. IAI engineers spent months diagnosing the issue and arrived at a solution that was as elegant as it was unconventional. They added 3 separate aerodynamic modifications simultaneously: swept canard foreplanes mounted above and ahead of the wing roots, a sawtooth extension to the outboard leading edge of the wing, and a pair of small strakes along the tip of the nose. Together, these changes transformed the aircraft's handling. Takeoff distances shortened. Sustained turn rate improved at every altitude and every speed. Gust response, the jarring instability and turbulent air that wore pilots down, was dramatically reduced. This became the Kfir C2. It was also the first production combat aircraft anywhere in the world to fly with canard foreplanes as standard equipment. A feature that is now common on almost every advanced fighter was pioneered on an Israeli modification of a French airframe using an American engine. The Kfir was also fitted with the ELTA EL/M 2001 fire control radar, giving it a look-down, shoot-down capability that the original Mirage 5 never had. What Israel had originally requested from France as a clear-weather ground attack aircraft had become a genuine multi-role fighter. The Kfir C7, the final major production variant, added 9 weapons pylons, updated avionics, hands-on throttle and stick controls, and multifunction displays. By the time it entered service in the late 1980s, the Kfir had been in continuous development for nearly 15 years. Total production reached 212 aircraft across all variants. In 1985, the United States Navy and Marine Corps leased 25 Kfir C1S, designating them the F-21A. They used them as adversary aircraft in dissimilar air combat training because the Kfir was agile enough to credibly simulate Soviet fighters. The Americans rented Israeli-modified French jets to teach their own pilots how to survive a real air war. That same year, another French aircraft was quietly finishing its own Israeli transformation. Chapter 3. The Sayar and the Barrel. Keeping old airframes alive, the Super Mystère. B-2 had been Israel's supersonic ground attack workhorse since the late 1950s. By 1967, it was already aging, and the French embargo made sustaining it almost impossible. The Snecma Atar 101G engine was heavy, unreliable, and dependent on French spare parts that were no longer coming. In 1968, the IAF launched the SAR program. SAR means tempest. The plan was straightforward. Remove the Atar engine from every Super Mystère in the fleet and replace it with the Pratt & Whitney J52, the same engine used in the A4 Skyhawk, which was then entering Israeli service. The logic was not only performance, it was logistics. Fewer engine types to maintain meant fewer spare parts to source, fewer technicians to train, fewer ways for the supply chain to break down in wartime. The J-52 was 25% more powerful than the Adir it replaced, lighter and significantly more fuel efficient. It had no afterburner, which meant the SAR was no longer viable as an interceptor. Israel accepted that trade-off willingly. The aircraft was redesigned as a dedicated ground attack platform, with additional weapons hardpoints and a ballistics computer for precision bombing. By 1973, all 26 Super Mystères in the fleet had been converted. The SAR modification had an unexpected consequence that only became apparent during combat. The J-52 installation required a different exhaust arrangement, which resulted in a slightly longer tailpipe that extended the heat plume further behind the aircraft. When the Yom Kippur War began in October 1973, and Soviet-supplied SA-7 Grail shoulder-launched missiles started destroying Israeli jets, analysts noticed that the SAR was surviving hits that killed unmodified aircraft. The longer tailpipe was pushing the missile's proximity detonation further back, away from the control surfaces and hydraulic lines in the tail. That observation triggered an emergency modification program for the A-4 Skyhawk fleet. Israel had been operating the Skyhawk since 1968, initially, acquiring 48 A-4H variants with twin DIFA 30mm cannons installed in place of the original American 20mm guns. By 1973, the Skyhawk was the backbone of Israeli ground attack aviation, and it was being destroyed at an alarming rate. At No. 22 Air Maintenance Unit at Tel Nof, engineers designed a nozzle extension for the Skyhawk's exhaust that mimicked the unintended survivability benefit of the SAR's tailpipe. They called it the Chavit, the barrel. The modification was designed, built, flight-tested over 4 sorties, and cleared for combat service in under 48 hours. The first modified Skyhawk was flown to IAI's facility at Lod Airport on the evening of October 20, 1973, and returned to its squadron the following morning. The extension added 10.6 inches to the aircraft's overall length and was subsequently fitted to every Skyhawk in the fleet. The Skyhawk had already been extensively modified before the war. In August 1971, the Crystal Upgrade Program brought older A-4E and A-4H airframes to near A-4N standard with higher-rated engines, improved heads-up displays, and updated navigation systems. In 2004, IAI installed Rada Electronic Industries ACE-2 avionics system across the approximately 50 remaining A-4N and TA-4J aircraft, replacing obsolete electronics with modern computerized debrief systems, capable of 3-dimensional flight reconstruction synchronized with video and audio recordings. The Skyhawk finally retired from Israeli training duties in December 2015, 48 years after it first arrived. That lifespan was entirely the product of Israeli engineering. Douglas Aircraft designed the airframe in the 1950s. Israel kept it flying into the 21st century. The Phantom arrived the same year the Skyhawk did, but its Israeli story went in a very different direction. Chapter 4: Heavy Hammer. The Phantom Israel almost reinvented. Israel received its first F-4E Phantoms in 1969. They named them the Kernas, Heavy Hammer. It was an accurate name. The Phantom was not an elegant aircraft. It was a twin-engine, two-crew, smoke-trailing machine designed to carry enormous loads at enormous speed, and Israel used it in exactly that way. Over the following years, IAI integrated Israeli-made electronics, weapons interfaces, and mission computers that no other Phantom operator was flying. In the 1980s, IAI proposed a comprehensive three-phase modernization program. The first phase installed new radar, heads-up displays, and updated cockpit instrumentation, along with software and hardware to support the Popeye standoff missile, an Israeli-developed weapon with a television-guided seeker capable of hitting targets from well outside the range of most air defenses. These upgrades were eventually applied to 55 aircraft. But IAI was also working on something more radical. In 1983, in conjunction with the development of a domestic Israeli fighter program called the Lavi, Boeing and Pratt and Whitney proposed replacing the Phantom's original J-79 turbojets with the PW-1120 turbofan. This engine was significantly shorter, more fuel-efficient, and produced roughly 30% more thrust. The transformed aircraft was called the Super Phantom. A prototype flew. The performance figures were impressive, and then the program died. The costs were prohibitive, estimated at $12 million per aircraft, and the Phantom airframes were already deep into their service lives. 2 months after the Super Phantom proposal gained serious traction, the Lavi fighter program was canceled under American pressure, and the PW-1120 engine had no other customer. McDonnell Douglas, the Phantom's original manufacturer, was also rumored to have lobbied against the upgrade, concerned that Super Phantoms on the export market would undercut sales of its new F/A-18 Hornet. What Israel did build was the Kernas 2000, a more modest but still significant upgrade that installed the APG-76 Doppler radar, a combined throttle and joystick control system, and full Popeye integration. The Kernas 2000 was among the most capable F-4 variants ever flown by any Air Force. It was retired in 2004. The knowledge IAI accumulated while developing it was later applied to an upgrade of the Turkish Air Force's F-4 fleet, called the Terminator 2020. Those aircraft flew combat missions over Syria. While the Phantom was being rebuilt in the hangar, the aircraft that would define the next generation of Israeli air power was already in service. Chapter 5. 17 changes, the F-16 goes. To war before America does Israel's first F-16A Nets, Sparrowhawk, arrived in 1981 under the Peace Marble 1 program. Before the aircraft ever flew an operational mission, IAI and Israeli military industries had already implemented 17 technical modifications. Most of them were in the software and mission computers. The goal was to allow the F-16 to operate Israeli-specific weapons that the standard USAF aircraft simply could not carry. Weapons developed domestically and not compatible with American software. On June 7, 1981, before any American pilot had flown an F-16 in combat, 8 modified Israeli Nets fighters took off and flew to Iraq. The target was the Osirak nuclear reactor outside Baghdad. The pilots flew at low altitude to avoid radar detection, crossed hundreds of kilometers of hostile airspace, and put their weapons on target in under 2 minutes. Each aircraft carried 2 Mk-84 bombs. The reactor was destroyed. No Israeli aircraft were lost. It was the first military destruction of a nuclear reactor in history, and it was carried out by an aircraft that had been in Israeli service for less than a year. The range to reach Osirak had required fitting larger external drop tanks than the manufacturer originally specified. That improvised range extension, a simple hardware swap, was the direct ancestor of modifications Israel would apply to the same aircraft 44 years later. In 1992, all IAF F-16A and B aircraft underwent a structural upgrade at IAI, Wings were reinforced. Elbit's advanced flight and mission management system was installed throughout the fleet, bringing the older airframes electronically to the same standard as the newer F-16Cs, while keeping the original F-100 engines. The F-16C and D Block 40, called the Barak Lightning, arrived in 1988. This variant integrated the Land-Tyrant targeting pod system, giving Israel the ability to conduct precision ground strikes in total darkness for the first time. In September 2007, Barak aircraft executed Operation Orchard, destroying a Syrian nuclear facility under construction near Deir ez-Zor. Israel kept the operation classified for over a decade. The F-16 Har Sufa Storm, delivered from 2004, was the most heavily modified F-16 variant ever built. Conformal fuel tanks were permanently integrated into the fuselage. All avionics were Israeli-developed. All weapons integration was domestic. The mission computer was designed and built entirely in Israel. Lockheed Martin considers the Sufa a unique configuration, distinct enough from the baseline F-16 that comparing the two requires understanding that they share an airframe and little else. Israel acquired 102 of them. It remains the most numerous combat aircraft in the IAF. As recently as 2025, the IAF modified older F-16C Barak fighters with extended-range fuel tanks that allowed them to reach Iran without aerial refueling, freeing the tanker fleet, including modified Boeing 707s that Israel has operated in the airborne tanker and early warning roles since the 1970s, to support other aircraft during the strikes. The Boeing 707 that refueled F-15 over the Mediterranean in 1985 during Operation Wooden Leg, the bombing of PLO headquarters in Tunis, was the same basic platform still supporting combat operations 4 decades later, with successive Israeli avionics upgrades keeping it operationally relevant. The tank solution in 2025 echoed the Osirak mission in 1981. 44 years apart, separated by 3 generations of aircraft technology, the same engineering logic. Extend the range of what you already have. The F-15 had already proven that logic on a larger scale. Chapter 6. The Eagle becomes something else. F-15 from interceptor to strike weapon. Israel's first F-15O Eagles arrived in 1976. They were called the Baz. Hawk. From the moment they landed, IAI fitted them with Israeli electronic warfare systems, weapons interfaces, and mission computers not found on any USA F-15. The Eagle was, in American service, an air superiority fighter. Israel turned it into a long-range precision strike weapon without changing the airframe at all. In 1985, 8 Baz fighters flew 2,800 miles round-trip from Israel to Tunis, refueled in flight by an IAF Boeing 707 tanker, and bombed the PLO headquarters in Tunisia. The F-15 had been designed to kill other aircraft. Israel used it to strike a target further from home than any Israeli aircraft had ever reached. No aircraft were lost. The F-15D Baz Meshapar introduced deeper Israeli avionics packages to the older fleet, extending its operational relevance well past the point where most air forces would have retired the airframes. Israeli F-15 accumulated 58 confirmed aerial kills across multiple conflicts with 0 air-to-air losses. That record has not been matched by any other aircraft type in the history of modern aviation. In 1998, Israel received the F-15I Ram Thunder. 25 aircraft, built specifically for Israel. Every sensor system was Israeli-sourced. Every weapon integration was domestic. Payload capacity exceeded 11 tons. Combat radius with aerial refueling was sufficient to strike targets in Iran and return. It was and remains the most heavily customized F-15 variant in existence outside the United States. In late 2025, a contract worth $8.58 billion was announced, covering the design and delivery of 25 new F-15IA aircraft for Israel, with options for 25 more. Work is expected to be completed by the end of 2035. The new aircraft will carry Israeli-specific electronic warfare, weapons, and communications systems developed and integrated domestically, continuing a modification tradition that began the day the first Baz landed in 1976. But the most consequential Israeli aircraft modification of the modern era involves a stealth fighter that nobody else was allowed to touch. Chapter 7: The Adir, modifying a stealth fighter. No one else could. On June 22, 2016, the Israeli Air Force received the first F-35A Adir at a ceremony in Fort Worth, Texas. Adir means mighty one. Israel had signed its letter of agreement with the United States in 2010, becoming the first country to select the F-35 through the American government's foreign military sales process. It was also the first foreign nation to receive the aircraft. And it is the only nation that has received American permission to extensively modify the F-35 with domestically developed systems. Every other country that operates the F-35 flies something very close to the Lockheed Martin baseline configuration. Israel does not. The F-35I carries a domestically developed mission computer, an Israeli-specific electronic warfare suite layered on top of the aircraft's existing avionics, and Israeli weapons integration. The modifications are classified in their specifics, but their strategic intent is not. Israel wants to maintain the ability to upgrade and enhance its F-35 fleet independently of the American procurement and development cycle, ensuring a technological edge that does not depend on Washington's schedule. The IAF declared the F-35I operationally capable in December 2017, following an intensive integration and training effort at Nevatim Air Force Base. The aircraft operates not only as a multi-role combat platform, but as a sensor node within Israel's wider integrated air and missile defense network, sharing data with ground-based systems and other aircraft in ways that multiply the effectiveness of the entire force. One of the F-35's fundamental limitations had always been its inability to carry external fuel tanks without compromising its stealth signature. External tanks dramatically increase radar cross-section, defeating the central advantage of a fifth-generation aircraft. Israeli engineers spent years developing a solution: range-extending fuel tanks that preserve the aircraft's low radar signature. In February 2026, Israel's ambassador to the United States confirmed publicly that IAF engineers had solved the problem. The Adir can now strike targets at distances previously impossible for a stealth aircraft without mid-air refueling. In April 2025, Lockheed Martin was awarded an $11.4 million contract modification to develop additional software data loads specifically for Israel's F-35 fleet. Work understood to reflect operational lessons from high-intensity combat against Iranian and Hezbollah forces. The Israeli Air Force is the only foreign service to have used the F-35 in sustained high-tempo combat operations. The modifications that resulted from that experience will shape how Israel flies the aircraft for decades. From the Shahak to the Adir, from the Nesher built with smuggled blueprints to the F-35I modified by agreement with the world's largest defense contractor. From the Chavit tailpipe extension designed overnight in a maintenance unit to the stealth-compatible fuel tanks that took years of classified engineering to produce, the thread connecting all of it is the same. Israel has never been able to simply buy what it needed and fly it as delivered. The embargo came. The war came. The threat evolved. And so the engineers went back to work. The Sa'ar was a super mystère with an American engine. The Kfir was a Nesher with an American engine and French aerodynamics redesigned in Tel Aviv. The Sufa was an F-16 that had been rebuilt from the inside out. The Ra'am was an F-15 that had never existed anywhere else in the world. And the Adir is an F-35 that only Israel is permitted to modify. Because Israel is the only nation that has demonstrated both the capability and the operational experience to make those modifications matter. That is the story of every warplane Israel ever modified. Not a catalog of aircraft, a record of what happens when a country has no margin for error and decides to treat that constraint not as a limitation, but as the starting point for every engineering decision it has ever made.